So here we have our problem, negative 34 plus 1/2 x is equal to negative 58. I'm going to go ahead and rewrite this problem so that way our addition is obvious. So we can rewrite this problem by saying, well, plus negative 34 plus 1/2 x is equal to negative 58. Okay, there's always a implied addition in problems like these, and I'm going to go ahead and show you by using an example with whole positive numbers. So for example, if I had the problem 2 plus 3x equals 5, for example, I just made that up, right? There's always an implied addition in front of this 2. This 2 is being added, okay, and 2 is just a number in the same way that negative 34 is just a number. So we are adding that negative 34 to our problem. Okay, so there's addition happening with that negative number. Okay, so that's the first thing that I want to show. The next thing that I want to do is I want to think about what is happening to my variable and in what order, so that way I know what I need to do in order to solve for my variable using my inverse operations. So the way that I kind of visualize that is that I know that I want to solve for my x, that's my variable, and I need to ask myself, well, what is happening to my variable first? What is happening to my variable second, according to my order of operations? So according to order of operations, right, we should know that this is implied multiplication happening here between this 1/2 and this x, so that comes first. So the first thing happening to my x is that we are multiplying it by 1/2, and then the second thing that we are doing to our solution there is that we are adding the negative 34 to that. So in order to get back to our x, we need to use our identity properties and what we know about inverses to get back to our x. So we need to start from the outside and work our way back in. So the first thing that we want to undo is this plus negative 34, and then we want to work our way in. We need to undo that multiplying by 1/2 in order to get back to or solve for our variable. So that's kind of how I visualize it, like these boundaries that are happening to my variable, and thinking about getting all the way back in through these boundaries or these gates or whatever. So the first thing, like I said, that we need to do is we need to undo this plus negative 34. So I'm going to use what I know about our identity property, creating zero pairs and the inverses to create a zero pair with this plus negative 34. Well, in order to create a zero pair with plus negative 34, I can go ahead and instead of adding negative 34, I can add a positive 34. Okay, that will create a zero pair here, and anything that I do to one side of my equation, I have to do to the other side. So I'm going to be adding a positive 34 to the other side of my equation as well. So now that zero pair no longer adds value to the left-hand side of my equation. So we are left with 1/2 x is equal to negative 58 plus positive 34. So I really don't have to write positive 34. There's always, that plus sign is always implied with positive numbers. So I'm going to go ahead and just write 34. So now on our right-hand side of our equation, we can simplify negative 58 plus 34. So we should be able to do that, but just visually, I would like to think of a number line. So let's say we had a number line, and we had 0 on our number line, and we had negative 58 also on our number line. So just visually, I just want to check to see what kind of answers would make sense for the simplification process, so that we know to get from negative 58 all the way back to 100, we would have to take 58 bunny hops to our right, but instead we're taking only 34 bunny hops to our right, right? And we're going right because addition implies that we are moving to our right on our number line. So we're going to still be in our negative because we're still to the left of our 0, right? We're still to the left of our 0, so we're still negative. We're just not as negative. So we're getting less negative. So our answer should definitely be a negative number, right? But it shouldn't be as negative as negative 58. So once you do that math, you will see that that number is negative 24, and that is still equal to 1/2 x. So now I know that in order to solve for my variable, the next thing, well, let's go ahead and cross it out. We have gone ahead and completed this first step of getting back to of solving for our variable. So the next thing that we need to undo is we need to try and get rid of this plus one half. It's not plus. We need to get rid of this multiplying by 1/2. So I know that I want this to be just x on the left-hand side of my equation. That's the whole point of solving for your variable, to get it isolated. But we also know that when we write x, that we're really just talking about 1x, right? We want to know how much 1x is worth. So but here we have a 1/2. So I need to find a way to make that 1/2 into a 1. So I need to create a 1 pair. So I'm going to go ahead and rewrite this again just for visual purposes. This is really the same as 1/2 times x is equal to -24. And in order to make this 1/2 into a 1, like I said I want to do, I know I need to multiply it by the reciprocal of 1/2. So the reciprocal of 1/2 is 2/1. And anything I do to one side, I have to do to the other side. So now on the left-hand side of my equation, I have 2/2 x is equal to -24, right? Because when we multiply our fractions, we multiply our numerators and denominators straight across. And now that just created a 1 pair. 2/2 created a 1 pair. And now I have my 1x here, okay, which I can just write as x. And on the left-hand side of my equation, we have -24 times 2/1. 2/1 is the same as 2. -24 times 2 is -48. So the solution to our equation here is x is equal to -48 as our final answer.